Welcome back. We are on chapter 4, Systems of Equations, and we're going to work today on section 4.3, Systems of Linear Equations and Problem Solving. The first objective here is to solve a problem modeled by systems of two equations. The steps are, the first one is to understand. You have to understand the problem. During this step, become comfortable with the problem. Some ways of doing this are to read and reread the problem. Choose two variables to represent the two unknowns. Construct a drawing. Propose a solution and check carefully, pay carefully attention to your proposed solution. This will help when writing equations to model the problem. Next step is to translate into two equations. Since we have two variables, we need two equations to be able to solve it. The third step is solving the system, and the fourth is to interpret the results. Check the solution in the stated problem and state your conclusion. Let's see here an example. One number is 4 more than twice the second number. Their total is 25. Find the numbers. Okay, let's read and reread the problem. Let's do this right now. One number is 4 more than twice the second number. The total is 25. Find the numbers. My suggestion, try to also explain to yourself in your own words the problem. And I'm gonna do it right now. One number is 4 more, that means 4 plus, 4 added. And then twice the second number. Twice the second number means 2 times. 2 multiplied by the second number. And the total, if you add them together, is 25. Alright. Suppose that the second number is 5. Then the first number, which is 4 more than twice, the second number would have to be 4 times. 4 plus 2 times 5 plus 5. We can see that this total is not going to be 25, so the numbers that we've guessed are wrong, but at least we tried to figure it out. We guessed some numbers and we understood a little bit better the problem. Since we're looking for two numbers, we let x be the first number and y be the second number. X and y are the clear choices. They're kind of popular letters to be used as variables, but actually you can use any letters. You can choose your own letters. Let's go with the tradition, right? X and y. Next step, translate. Now you understood the problem, you know how to explain the problem with your own words. Now translate into math. One number is 4 more than twice the second number. So one number is 4. One number x equals 4 more than twice the second number, and the second number is y. And the next statement is their total is 25. That means x plus y equals 25. Okay? Then we have now 2 equations and 2 variables. We have a system of equations with 2 variables. Right now, let's solve. We can choose a method we can remember that we have basically three methods to solve the equations. One is the graphing method, another one is the elimination method, and the other one is substitution method, right? You can choose one. I'm going to choose for this one the substitution method, because we have x equals 4 plus 2y, and we don't need to work a lot to find x is already here. We can substitute this first equation in the second one. That means instead of x here, we're going to write 4 plus 2y. 4 plus 2y plus y equals 25, right? And we have like terms, combine like terms. We have here 2y is a like term with y, so let's combine 2y plus y is 3y, and we apply addition property. Subtract 4 from both sides, then we will have 0 plus 3y equals 25 minus 4, 21. Think a little bit about it. We have 3y equals 21. What would be the next step? Well, multiplication property, right? Divide both sides by 3. Divide both sides by 3. Then you will have y equals, because you simplified, 21 over 3, 7. Great! Now we found a value for y. We can plug this value here in the first equation and find x. X equals 4 plus 2 times what? 7. That means x equals 2 times 7, 14 plus 4, 18. X equals 18, y equals 7, the order pair, if you want to represent as an order pair, 18 and 7. Next step here, interpret. Let's substitute 18 and 7 into both of the equations. If you substitute x equals 18 and y equals 7 in the first equation, you're going to produce a true statement. And if we substitute x equals 18 and y equals 7 in the second equation, same thing, true statement. That means the two numbers are solution for the system of equations. And finish this example here. Let's try another example. Now we have this question. Hilton University Drama Club sold 311 tickets for a play. The student tickets cost 50 cents each. And non-student tickets cost $1.50. If the total receipts were $385.50, find how many tickets of each type were sold. Okay, first step, understand, read and reread. Suppose you can explain to yourself in your own words the problem, and you can guess numbers and try just to be able to understand better the problem. You're not trying to solve the problem, we're guessing numbers here just to try to understand better the problem, right? Suppose the number of student tickets was 200. Since the total number of tickets sold was 311, the number of non-student tickets would have to be 111. Okay, all right, that's because 311 minus 200 is equal to 111. The total receipts are $385.50. This is total amount of money collected. And the admission for the 200 students would be the students would be 200 times the ticket price of for students, right? 200 times 50 cents or $100. Therefore, admission for the 111 non-students will be 111 times 1.5 equals $166.50. This total is not equal to the total that is stated on the question. That means this solution that we guessed is incorrect. But never mind, because we are using this to understand the problem. We're not trying to solve the problem, we're guessing numbers to try to understand the problem. Okay? Let's label the variables. Since we're looking for two numbers, we can let S be the numbers of student tickets and N the number of non-student tickets. Again, you could use X and Y, you can use any other letters, you can label using the letters that you want. Now you label your variables, S and N. Let's translate into math. Hilton University Drama Club sold 311 tickets for a play. This is the total number of tickets. That means if you add S, the number of student tickets, plus N, the number of non-student tickets, then you're going to have a total of 311. Total receipts were 385.50 cents. And I'm going to repeat here. If we have 50 cents, right? 50 cents is the price of student tickets, multiplied by the number of student tickets, added by the price of the non-student tickets is 150, multiplied by the number of non-student tickets sold is equal to 385.50 cents. We found two equations with two variables. Now we have our system of equations. Now let's solve the system of equations. Repeating here, so you can always remember that we have three methods. We have the graphing method, we have the elimination method, and we have the substitution method. I think I'm gonna use here the elimination. And to use the elimination, what I'm gonna do, I'm gonna multiply this second one, the whole second one, by -2. I'm gonna multiply by -2. Okay. -2 times 0.50 s is going to be minus s, minus 1s. -2 times 1.5, -3, equals a -2 times 385.50 cents is going to be 177. Let me just check with my calculator here. I don't want to give you the wrong number. 385.5 times 2. Great, I'm still doing correct calculations. Okay, add both equations, s minus s 0, n minus 3n minus 2n, and 311 minus 771 is going to be 0, 6, and 4, right? Divide, apply multiplication property and divide both sides by -2, then you're going to have n equals 230 tickets. That means 230 tickets sold to non-students. Let's plug in this on the first equation. S plus 230 equals 311. S equals 311 minus 230. 311 minus 230 equals 81. S equals 81. Now the last step, interpret the results, check by substituting the numbers that you found, S equals 81 and N equals 230, right? On the first and on the second equation. If you get a true statement on both equations, true and true, then you can finally conclude that the numbers S equals 81 and N equals 230 are the solution for this equation, and you can state that actually the answer to the question. There were 81 students' tickets and 230 non-student tickets sold. Finish this example. Let's work another example more. And okay, let's work this one. New question. Terry Watkins can row about 10.6 kilometers in 1 hour downstream and 6.8 kilometers upstream in 1 hour. Find how fast he can row in still water and find the speed of the current. So we need to find the speed of the current and how fast he can row in still water. Read and reread. This is the first step to understand well the problem. We have to read, reread. I like to say you try to explain to yourself the problem with your own words. We are going to propose a solution. We're going to guess a solution, but first we need to understand the formulas we will be using. The basic formula we will use is distance equals rate, that means speed, times time. Okay. We have the effect of the water current in this problem, and the rate when traveling downstream would actually be R, that means the rate of the rowing, plus the speed of the water, the speed of the current, right? And if we calculate the rate upstream, it would be R minus W, where R is the speed of rowing and W is the speed of the current. Suppose Terry can row 9 kilometers an hour and the water current is 2 kilometers an hour. Since the row he rows for 1 hour in each direction, downstream would be R plus W times T equals D, and we can plug in the numbers. 9 plus 2 times 1, 11 kilometers. And upstream would be R minus W times T equals the distance, or 9 minus 2 multiplied by 1, which is equal to 7. That's obviously our solution is wrong, because the purpose here is not to find the right solution. The purpose is actually to understand the problem by guessing some numbers and checking it out. Okay. Now we understood the problem. We know what the problem is asking. We know the information that we have. We labeled our variables. R is the rate of the rower in the still water, and W is the rate of the water current. Now translate into math equations, and we know that the rate downstream is going to be R, which is the rowing speed R, plus W, which is the speed of the current. Okay. The time downstream, 1 hour, and this is going to be equal to the distance covered downstream, 10.6 kilometers. Okay, and now the rate upstream is the R, the rate of rowing, minus W. Now upstream the current, the water current is like holding back, right, the rower, times the time rowed, 1 hour, equals to the distance covered, 6.8. And I'm gonna have this system of equations. The next step is to solve, and we can choose graphing, we can choose elimination method or substitution methods. Graphing is usually for some very specific problems that are complicated to work out on substitution or elimination methods, or when the question asks for graphing. We're usually going to choose between substitution or elimination methods. And this one is a good candidate, a good choice for the elimination method, because I have here positive W and negative W. And if we add together these equations of the system, we're going to have R plus R, true R, positive W minus W, 0, and 10.6 plus 6.8, 17.4. Right? Next step, we have 2R equals 17.4. Multiplication property, divide both sides by 2. Then, as a result, we're gonna get R equals 8.7. We found R, now we're plugging in the first or in the second equations the value of R. Let's plug in on the second equation. 8.7 minus W equals 6.8. And we can add, let's subtract 8.7 from both sides, right? Subtract 8.7 from both sides. Then we have here 0 minus W equals negative W. 6.8 minus 8.7. Then we will have 1.9, right? W equals, multiply by or divide both sides by negative 1, you have W equals 1.9. Interpret the results. Actually, you have to get the numbers that you got. R equals 8.7 and W equals 1.9, and plugging in both equations to check if they produce a true statement. And checking here, we can see that in the first equation you're going to produce a true statement, and if you plug in the second equation, you're also going to get a true statement. And finally, you will answer your question. And to answer your question, one of the things that you have to take good care is about the units. Because the first R and the second one are speeds. Both R and W are speeds. And the distance was in kilometers, the time was in hours, so the rate or the speed is going to be the kilometers per hours. Terry's rate in still water is 8.7 kilometers per hour. and the rate of the water current is going to be 1.9 kilometer per hour. Done with this example. Finished. Concluded. Let's go to the next one. Let's work a new one. And we have a new example here, which is about a candy barrel. Shop manager mixes M&Ms worth $2 per pound with trail mix worth 1.5 per pound, $1.5 per pound. How many pounds of each should she use to get 50 pounds of a party mix worth $1.8 per pound? And this problem we have to read. First step, we have to read, we have to reread, and in order to understand, I'd like to think about explaining to yourself in your own words. Try to explain the problem to yourself using your own words. And another thing that we can do, as you've seen before, we can guess a solution. And actually, let's first understand the formulas that we will be using. The first one is the cost of any quantity of item. Then we're going to use this formula here. The price per unit times the number of units equals the price of all units. Suppose that the manager decided to mix 20 pounds. We're guessing here this amount, this quantity, 20 pounds. And the objective here is not to find the solution, but actually to understand, to do the calculation, to do the calculations and understand the problem. Since the total mixture will be 50 pounds, we need 50 subtract 20 equals to 30 pounds of trail mix. Substituting each portion of the mix into the formula, then we have M&Ms, $2 per pound, and we have 20 pounds, multiply 2 times 20, $40. Trail mix, $1.5 per pound. We have 30 pounds, multiply, then we're going to have $45. Then the mixture you're going to have to add together. If you have the mixture at $1.8 per pound, multiply by 50 pounds, is going to be 90 pounds. But actually, if you add the $40 of the first of the M&Ms with the $45 of the trail mix, then you're gonna get $85. That means the numbers that we guessed are wrong. But no, never mind, because we're trying these numbers, we're guessing these numbers actually to understand the problem. Next step, let's translate into math equations. And if the total amount is 50 pounds of party mix, that means, let me see, we labeled the X as the amount of M&Ms, okay, and Y is going to be the amount of trail mix. If X is the amount of M&Ms and Y is the amount of trail mix, if add X and Y, we need to have 50 pounds, right? That's the total amount of party mix. And the prices, we have the prices per unit, and the price of M&M is $2 a unit, right? $2 a unit. If you multiply it by the amount of M&Ms, X, then you add the price of trail mix, $1.5 units, times the amount of trail mix, Y. This is going to be equal. It needs to be equal. We want this to be equal to 1.8. That's going to be the price of the mixture, times the total amount of mixture, which is 50 pounds. And we have a system. Now we have a system. X plus y equals 50. 2x plus 1.5y equals 90, which is 1.8 times 50, right? 90. And again, repeating the same thing. You can choose. You can use graphing, but graphing is, as I told you, you're going to use for some specific, some more particular problems. Usually going to be a choice between elimination method or substitution method. And here I think I like the substitution method. I like the elimination method. I'm gonna multiply this first one. By negative 2. Multiplying the first by negative 2, and I'm gonna repeat here down underneath this equation. Negative 2 times x, negative 2x, negative 2 times y, negative 2y, negative 2 times 100, that times 50 is negative 100. Now add these two equations. Negative 2x with 2x, 0. Negative 2y with 1.5y, negative 0.5 y. And negative 100 minus 90, negative 10. And we can, right now, can you see we have negative 0.5y equals negative 10. We can divide both sides by negative 0.5. If we divide negative 0.5 by negative 0.5 is 1. So y equals negative 10 divided by negative 0.5. Negative with negative positive. 10 divided by 0.5 is 20. This is going to be y. Plug in y in the first or the second equation. Let me see, I'm going to plug in the first equation. X plus 20 equals 50. X equals 50 minus 20, 30. And that's the solution that we found. Let's interpret results by checking the numbers that we have found. X equals 30 and y equals 20. Plug in the first equation, check the result. If it's a true statement, you plug in then in the next equation, the second equation, and if both are true statements, then you can confirm this is a solution. This is the solution for our problem. And at the end, you state the solution. You can express your solution like we can see here. The store manager needs to mix 30 pounds of M&Ms and 20 pounds of tray mix to get the mixture at $1.8 a pound, or $1.80 a pound. Another example covered, another example finished. Let's see, and now we have a new objective. Is to solve problems with costs and revenue functions. Now let's read and reread this new example, understand, and then we go to the next step. A company that manufactures boxes recently purchased $2,000 worth of new equipment to make gift boxes to sell to its customers. The cost of producing a package of gift boxes is $1.50, and it is sold for $4. Find the number of packages that must be sold for the company to break even. And one thing that you have to understand that means break even. Here, break even. Break even is when the cost of production is equal to the cost of the revenue, the sales, right? This means break even. You don't lose money, but you don't make money. Is the point where you covered all your costs, you break even. To understand, the company will include a one-time cost of $2,000 and then $1.50 per packaged product. The revenue will be $4 per package sold. If we label, let's label here the variables, and the X, we're going to call X the number of packages of gift boxes. C of X is the total cost, is a function of X that will represent the cost, and R of X is a function in X that represents the revenue. Translating into math, we will have the revenue. The revenue is, oops, wrong pen. We're going to have the revenue Rx equals $4 each item sold, right? Each gift box sold. So $4 times X. This is the revenue. And the cost. This is the total revenue. And the total cost. The total costs are going to be $2,000 is the amount that is spent just one time for the fixed costs, the amount that is represented here by the purchase, the equipment that was purchased to make the gift boxes, right? Is the machinery, all the machinery acquired to produce the gift boxes. So it's $2,000 plus 1.5 is the cost of each, the cost of production for each gift box multiplied by the number of gift boxes produced. This is the total cost. Since the break-even point is going to be when revenue is equal to cost, then we make Rx equals Cx. That means 4 times X equals 2,000 plus 1.5x. Let's solve this equation here. And to solve the equation, remember, you have to simplify, you have to apply addition property and multiplication property. In this situation, let's subtract 1.5x from both sides. Then we will have here, this is 0, 2000 plus 0 equals 2.5x. 4 minus 1.5, right? To 2.5. And x is going to be equal to 2000 divided by 2.5, which is 800. That means that to break even, the company needs to produce and sell 800 gift boxes. To see whether the break-even point occurs when 800 packages are produced and sold, check see if the revenues equals costs when x equals 800. And we can see here, if we calculate, the revenue is going to be $3,200 and the cost is going to be $3,200. If they are equal, means we can confirm this is the break-even point. And now states the solution: the company must sell 800 packages of gift box to break even. Very good. And finished with this example. Now we start with objective 3 and solving problems modeled by systems of 3 equations. Instead of 2 equations, now we have 3 equations. And going straight to an example, the measure of the largest angle of a triangle is 90 degrees, more than the measure of the smallest angle. And the measure of the remaining angle is 30 degrees, more than the measure of the smallest angle. Find the measure of each angle. So understanding the problem, we have to read, reread, say in your own words, explain the problem to yourself, and you can propose, you can guess a solution just to understand, to work out the calculations and understand better the problem. Suppose the measure of the smallest angle is 30 degrees. Then the largest angle is going to be 30 plus 90, 120 degrees. And the remaining angle is 30 plus 30 equals 60 degrees. But you know that in a triangle, the sum of the measures of the three angles is going to be equal to 180 degrees, right? But if you add up the angles that you just guessed, you're not going to have 180 degrees. That means the solution is wrong, is incorrect, but at least we got the understanding of the problem. Let's translate now into equations, and we're going to have S. This is the part where we label the unknown quantities, the variables, right? We can call S the measure of the smallest angle, M the measure of the middle angle, and L the measure of the largest angle. And solving, we know that if we add all the angles together, S plus M plus L, they are angles of a triangle, so it's 180 degrees. The largest angle, the largest L, is going to be equals to the smallest one plus 90. This is given by the problem, right? And the one in the middle, the next one, the one in the middle, is going to be 30 degrees, the smallest, plus 30 degrees. And we have here a system where we have 1, 2, 3 variables, right? And we have 1, 2, 3 equations. Let's solve the system and try to figure out the values of the angles. Okay, let's solve the system of equations. And this system, we have one equation that have all the variables. Let's show you here. This equation here have all the variables, like S plus M plus L equals 180 degrees. Let's try to substitute into this equation the other variables. You're going to substitute and selecting only one variable to be to represent the other ones. So at the end we're going to have just one variable in the whole equation. So check out the other equations that we have. We have L equals 90 plus S, and we have M equals 30 plus S. And that's very good because we have the value of L here that we can plug in into the first equation. When you have a value here, an expression here for M that we can plug in the first equation. Everything as a function of S. So at the end, after I make the substitution here on the first equation, I'm going to have a whole equation all as a function of S. So let's write here S plus M is going to be equals to 30 plus S. 30 plus S plus, and L is equal to 90 plus S. And adding all together, we're going to have 180. Combine like terms. Next step, combine like terms. And we have S, S, and S. That means 3S. And we have 30 and 90. Oops, wrong pen. 30 and 90. Then 120, right? 30 plus 90, 120 equals 180. Addition property, subtract 120 from both sides. Now we're gonna have 3S equals, this is 0, and this is 180 minus 120, 60. Divide both sides by 3, then you get here, let me show up here, S equals 60 divided by 3, 20. Plug in, you have S equals 20. Plug in here, L equals, let me just plug in here, 90 plus 20 equals 110, and plug in over there to find M. 30 plus 20 equals 50. Substitute S equals 20, M equals 50, and L equals 110 into all three equations. So check into all three equations. The first one we checked it, true. Check the second one, it's going to be true, and check the third one. If it's true as well, then you can confirm the three angles of the triangle are going to be 20 degrees, 50 degrees, and 110 degrees. This concludes section 4.3. Thanks for watching.